Ready? Okay, this is going to be trial 2 for our heat of neutralization experiment number 5. I'm pouring out 30 mils of the 2 molar hydrochloric acid again. So we're going to get the bottom of that meniscus right on that 30 mil mark. Not quite there. Now I'm over it. Gotta get rid of some. Okay. There's our 30 mils of hydrochloric acid. We're going to pour it into this beaker so we can get our temperature of it in a few minutes. We're going to do the 30 mils of the base of the sodium hydroxide. New graduated cylinder, because if we poured it in the original one, we would have started the reaction in the graduated cylinders rather than the calorimeter. Okay. There's our 30 milliliters of the base. Pour it into the beaker. So now we've got to check the temperatures of both solutions, making sure that they're not greater than ½ degree in temperature so we can get our temperature at time 0. I got to wash the thermometer as I move from one beaker to the next. So right now, this solution is at 20.10. So write that down, 20.10. You're somewhere over to the side, not there. Somewhere over to the side. Washing off the thermometer, drying it, going to the base solution, checking its temperature. And it appears that the base is somehow warmer. It looks like it's going to be getting closer to 20.80. So how far apart are those two? 20.1 and 20.80, so that's 0.3 degree difference. So we can go ahead and use that. If we'll average these two, that's going to be our time 0. What's the average of those two numbers?
So 10 point how much? 9 point 18 199 9.95.
20.95.
Sorry, 20.95.
Okay, so that's our temperature at time 0, 20.95. Okay, so we're going to get ready to mix our solutions in the calorimeter. Remember, the heat of reaction is exothermic, so it's going to be giving off heat, and we're going to measure that heat it's giving off by the amount of heat that this solution we're making is absorbed.
Can I start now?
No, you tell me when to start. Okay, you watch your clock and you tell me when to pour, and then we're going to start the 15-second count. So you tell me when.
Let's start.
Now?
Yes.
Okay.
Yes.
The temperature should be jumping up real high as these reactions, the molecules bump into each other. Yep, we're up above 30, headed toward 31. You ready for the next one?
Yes.
31.00 is what it was. Now we're continuing to jump up. We're going up over 32 now. Tell me when the next 15 seconds is over.
Yes. Next.
32 point, no, we're at 33.10. 33.10. Now we've gone up above there.
Next.
33.40.
Next one.
33.45.
Next one.
33.40. So it's starting to drop. Yeah, we're starting the cooling curve now.
Next one.
33.25.
Next.
33.20.
Next one.
33.05. 33.05.
Next one.
33.00.
Next one.
32.95.
Next one.
32.80.
Next one.
Looks like it's still at 32.80.
Next one.
32.75.
Next one.
32.70. Okay, we'll do one more just to be sure.
Next one.
32.60. All right, so now that's 10 temperature measurements beyond the max that we observed. So we've got our data collected. If you want to get a close-up on that. For trial 2. So for trial 1, the maximum observed temperature that we actually saw on the thermometer was this one for trial 1. For trial 2, the maximum observed was this one. Here was our initial temperature for trial 1, our initial temperature for trial 2. To get the delta T for this particular change, we're not going to use these two maximum observed temperatures. We're going to graphically make a calculation to get a better temperature that we could not see on the thermometer, and I'll do that explanation in just a few minutes on another file. But I wanted you to be able to see these temperature readings, and you probably want to transfer these numbers to your own data chart on page 30 from your lab manual. Okay.